Hello everyone and welcome back to the math. In this video, we are going to learn about composite function. If you haven't watched the previous video regarding the domain and range of function, I'll leave the link of the playlist in the top right of this video. Right, before we go into the technical details of composite function, let's try to see a simple example. Let's say that I have a dirty t-shirt and this in function is going to be our input. Now, let's say that we want to use a washing machine to wash it. So the washing machine is going to be our function. Let's say that this is a function g, which is used for washing. After this, we know that we will get an output, which is a wet t-shirt. So this is going to be the output, which is gx. So from a dirty t-shirt, go into the washing machine and we get a wet t-shirt. But we're not done yet. Remember that the t-shirt is still wet. It's not dry yet. So we have to use another function of the washing machine. To actually dry the wet t-shirt, we're going to use the drying function of the washing machine. But now, the wet t-shirt is not an output anymore. It's going to be an input. It's going to be a new input for the function f, which is the function for drying. After this, we know that we will get an output, which is output f of x, where it is a clean, dry t-shirt. So that is a simple analogy for a composite function. It's basically a function that comprises of other functions. Now we understood that composite function means a function that comprises of multiple other functions. So in the case of the washing machine, we know that the input is going to be a dirty t-shirt, and we have several functions. Let's say function A in the washing machine stands for washing, function B stands for bleaching, and function C stands for drying. And now we know that the output is going to be a dry, clean t-shirt. Now, let's try to see what composite function is in mathematics. We first try to learn how to write composite function. Let's say that we have f of x and g of x. If we want to make the composite function basically a combination of the two, it's going to be fgx. So fgx actually stands for a function f where the input is actually g of x. So we have a function inside a function. Now, how to actually solve for this composite function? So first, we are going to do gx, and then we're going to do f of x. So we're going to do it from the inside to the outside. You might not understand it completely now, but we will get into the examples later on. The next way to actually write a composite function is going to be gfx. And fgx is different from gfx, as we will see later. So to write gfx, it's going to be function g where the input is f of x. Again, it's going to be a function inside a function. And to actually solve for this composite function, we are going to work on f of x, then we go to g of x. Again, from the inside to the outside. We can also write fgx as fogx, but I'll try to make it simpler by writing it as fgx only. And we also need to know that the composite function fg only exists if the range of g is inside the domain of f. So rg is going to be the range of g, df is going to be the domain of f. Let's try to see what this actually means. Right, we know that fg is going to be fgx, technically the same, and fgx is going to be a function f with the input of gx. Now, let's say that we have an oval diagram that represents all the values of the range of gx. So the range of gx is going to be represented by this oval diagram. And now, all the values of the range should be inside a bigger oval, which is the domain of f of x. So the range should be inside the domain. That's what the above sentence actually means. So the range of gx should be inside the domain of f of x. What happens if the range is outside the domain? Then the composite function will not be defined. If the range is outside the domain, the composite function will not be defined. That's the rule in mathematics. We can actually see another example where we have gf, and the composite function gf only exists if the range of f is inside the domain of g. So we're going to make it like this again. G of x means a function g where the input is f of x. And let's say we have another oval diagram that represents the range of fx. And these range of fx should be inside the domain of gx. That's what it meant by the above sentence. Okay, you might be wondering, is this going to be useful in this specific material? Well, in the IGCSE exam, usually, we don't actually need to fret about the domain and range of a composite function. It's actually very difficult to solve those kind of problems. So you don't really need to overthink this. You can just try to consider this as an extra knowledge, okay? Right, let's try to see the first example. Suppose that we have f of x is equal to 2x, where the domain is any real values, and we have g of x equals to x plus 1, where the domain is again any real values. Now, usually for the problems, again, we don't really need to fret about the domain and the range of the composite function, okay? Now, the problem asks us to find fgx. Okay, let's try to remember what fgx is. Fgx is going to be the function f with the input of gx. So we can try to input gx equals to x plus 1 inside the expression, which will look like this. And then we can try to input the expression of f. We know that f is actually 2x, but now we change the x into x plus 1, which will look like this. So that is the composite function fgx. Pretty simple, right? Let's try to take a look at the next example. Okay, so now we have to find gfx. Again, we have to remember what gfx is. Gfx is going to be a function g with f of x as the input. So now we can try to input f of x equals to 2x inside the expression, and we got something like this. After that, we can try to input the expression of g, and we get that gfx is going to be 2x plus 1. So we just need to substitute 2x into x for the expression of g. So it's going to be 2x plus 1. Now, remember that fgx is 2 times x plus 1. So we can try to get a conclusion that generally, gfx is not equal to fgx. There are some functions which is equal, but generally it's not equal. Okay, let's try to go to the next example. So in this case, we have f of x is equal to 2x plus 3 for any real x values, and g of x equals to x squared plus 1 for any real x values. And we want to find fg3. So in this case, the x is replaced with 3. The first step, again, we can try to find the composite function first. So fgx is equal to the function f with gx as the input. We can try to substitute gx equals to x squared plus 1, input it into the expression, and then we are going to get something like this. And then we can try to input the expression of f. So we got that the composite function is going to be in this form. Now we can try to input x equals to 3, which will look like this. So in the end, we know that fg3 is equal to 23. Now, I want to take your attention to this part. Sometimes in the exam, we might get a composite function that is quite complicated, but the question is, should we simplify it? For this specific example, it's easy to simplify, right? But what happens if we have a complicated expression? The answer is, it's optional if we want to simplify it or not. If it's asked in the problem to simplify, then we should simplify it. But if it's not asked in the problem, then we don't need to simplify it. Right, next example. Now in this case, it's going to be a different type than the previous examples. So we have f of x is equal to 1 over x minus 1 defined for any real x values except when x is equal to 1, because we know that if x is equal to 1, this function is undefined. And now we have to find ff3. So what is ff3? First, we need to know what is ffx. Ffx is technically the function f with f of x as the input. So it's the same function inside the same function. It's a bit weird, but this kind of function exists. Right, the first step that we can do to solve this, we can try to input the expression of f of x. So it's going to look like this. And then we can try to input the expression of f again. So we can try to replace the x with 1 over x minus 1, which will look like this. Now, I will try to simplify this a bit so that you can get a simpler expression. So first, we can try to simplify the denominator, and then we know that we can get this expression. Continuing from the expression before, we can try to flip the fractions. So this is the simplified expression of f of x. And now we can try to input x equals to 3, and we get that ff3 is equal to minus 2. Again, if you are being asked to simplify the composite function, then you need to simplify. If it's not, then you don't need to simplify it. Right. Now, next example. Now we know that f of x is equal to x squared minus 3x defined for any real x values, and g of x is equal to x plus 3 defined for any real x values. And now we have to find x such that fgx is equal to 4. So in this case, we have to find the x. But again, first we have to find the expression of the composite function. Again, fgx is going to be the function x with gx as the input. So the composite function is going to look like this. And then we can try to input fgx equals to 4, which will look like this. The next step, as you guessed it, we can expand, simplify, and solve for x. So we can try to expand it, and we can simplify it. We get a nice quadratic equation. And we know from factorization that the x can be 1 or minus 4. Okay, so this is the last example. We are going to use the same functions, but in this case, the problem will be different. We need to find k such that fgx equals to k has 2 real solutions of x. So we want to find the k such that this equation has 2 real solutions of x. Now, in the case of 2 real solutions, it can be 2 distinct real solutions or 2 identical real solutions. I think you can already guess where we are going with this. So first, we can try to write again our composite function, and then we can try to input fgx equals to k. So it's going to be like this. And then we can try to expand and simplify, so we get a nice quadratic equation. Now, we have to find the k, and we know that if we want to find 2 real solutions, again, it can be distinct, it can be identical, so the discriminant can be bigger than or equal to 0. And remember that discriminant is b squared minus 4ac. So we just have to input the ABC values, and we get ourselves a nice linear inequality. So we get k is bigger than or equal to negative 9 over 4. Okay, so these are the exercises that I've prepped for you guys. I hope you can try to do them, and the answer, as always, is in the description box below. Right, so that's it for this video. In this video, we learned about composite functions. What do you think about this video? Please leave a comment, and don't forget to leave a like, and don't forget to subscribe. I'll see you on the next video. Thank you.